thanks a lot for the invitation. I hope I can give you a little bit of insight on some of the prospects, I guess, for having a Nordic quantum powerhouse. And allow me just to start by saying that if you look at the Nordics, I'm not speaking about Denmark now, I'm looking at the Nordics. If you look at the Nordics, we have some super tradition for talent, education, for science, for connecting science to companies, industry, for having a society where people can thrive and have a good time and be happy with their kids and stuff like that. We should bank on that. I have a few humble ideas about how that can be done. Quantum is, of course, one of the many possibilities for the Nordics, and that's what I'm going to concentrate here today on. This is just a plateau of what's going on in Denmark on quantum. There's different things happening there, as you might see. And as has already been told about and reported here, there's quite a bit of activity also in Denmark on quantum. There's quite a bit of political initiatives supporting the various quantum initiatives that we have in Denmark, but there's also a number of investments there, as already been told by Ebba. So I will not go into the details there. I can say maybe in 21, where things in Denmark really started up on the quantum scene, was when we had Blinken visiting on the Niels Bohr Institute, and I think that was sort of that contributed to sort of the focus on Denmark. Of course, there's a number of other people that has visited us since then. So allow me just to say a few words now. You said the operating system of nature, which I think is a great frame for what quantum technology really is. It is the deepest understanding, in my view, of nature. Sort of the core architecture of nature and dictating how that should be. And I call it here the blueprint of nature, essentially. So there's a number of interesting things going on in this magic world that we can harness for health science, for defense, of course, as well, economies. There's a number of things that we could harness from this amazing technology, and we don't have enough time to speak about it today. But I will give you a few sort of points where I think that we've already seen fabulous examples for on the sensor side, on quantum sensors, what they can be used for. There's a huge potential here that we can have. Not only for quantum sensors, but also for a number of other things here. This is just a view of, an artist's view of how quantum physics is operating. And I don't know if you can get anything out of it. It looks messy, and I guess quantum is, to some extent, messy. Allow me just to bring forward a number of the strongholds that I think we should bank more on. As just said before, so talent and education, I think, is one of the things that we should bank on. That is sort of on a very high level in the Nordics. We have a very strong scientific base. It's not only sort of are we catching on. If you look at the Nordics, there's many places at the universities and our institutions where we are not only sort of number 3 or number 5 or something like that, we are number 1. And if there are places where we are number 1, we should immediately bank on those places and bank on that technology that comes out of those places. And we have several of those in the Nordics, and I think that's important. We have innovation hubs. We have an emerging industry. Now, I've seen countless examples of an emerging industry from Sweden here. I think last time, when you were in Copenhagen, we discussed, the emerging industry of quantum technologies in the Nordics. That you said that you had a number of initiatives with Saab and Volvo and IKEA. And I think the statement that I had in my mind was, if you can make IKEA use quantum technology, you will declare victory. Basically, that's you cannot go any further than that. That will be sort of the end. But you can see in Denmark we have about 35 quantum companies as it is right now since 2021, up 3 to 5, and you see similar numbers for Sweden and Finland actually. And we have as a speaker later on here that has her own company, right? So that's we are very eager to hear about that also. So there's a number of companies also in Finland. We have Norway as well that banks in with interest, and I think that's an important point to have here, that we have an industry. It's not only academia, it's actually an industry that comes money out of it. There's also supporting centers. We have heard about the centers here. We have a number of great initiatives also supported from foundations, but also from the government. And I think this is another stronghold of the Nordics. If you count the amount of centers of excellence, as we used to call them in the science, it's an amazing amount of numbers that you will see in the Nordics. And we say per capita and things like that. We don't even have to say per capita here. We're simply some of the best on this. So I think this is another issue that we should bring forward here. We have ambitious national strategies. Sweden is about to launch its cultural strategy. Finland the same. We will have one from Norway as well. I think that's a great starting point for good collaboration in the Nordics, and a stronghold that we have some strategies to put on. And then we have strong funding schemes that we already mentioned. And then we have a high capacity infrastructure. It's not only a good infrastructure, it's a high capacity infrastructure in several ways. Then we just mentioned too from Sweden here, the ESS that's about to be finished in a couple of years. We have to wait a little bit yet, I guess, but you have probably the latest data on that. But this will be, if you look at ESS, the European Spallation Source, from outside, and the entire area around that, in terms of material science, for example, that will be a complete game changer. So now we are banking on a complete game changer. In Sweden, just next, not too many kilometers from here, we have Max 4, a great game changer in terms of material science as well. So this is another stronghold, and we will have several of these initiatives in the other countries as well, just to give some examples. So a high capacity infrastructure. Now, here comes then to, where is it that we need to think about? I mean, what is it? I mean, we can have giant infrastructure, but we need to make sure that we don't double up where we don't need to double up. Of course, sometimes you need to double up because you need to go fast. But if you don't need to go fast, maybe you should think about how to use the resources. Educational programs. We are not sort of, 100 million people here. I think in Nordics we're about 25 million or something like that. If I do fast here, we have Iceland, of course, as well. And we could do maybe super high programs of quality that can compete with MIT and whatnot on these things. So I think we should think about that. Joint research centers, funding for joint research, academic partnerships with companies, not only in your own countries, but maybe with different countries. I think we should have some Nordic innovation hubs where we have industry and academia going together. And some joint funding possibilities, I think, would be sort of the political framework that I could see could happen here. That you need some kind of political framework. I know the scientists are already there, they are already together. We are already formed the group and meeting regularly. We need a political framework or basis, I would say, for this willing to take off. So this was just to give a few fast inputs on that. And then I could not resist giving also the talks that I've heard before. Fabulous to see, absolutely fabulous to see what's going on in medical science with quantum sensors right now. And I just wanted to bring back the optical pump magnetometer and tell a little bit about that sense. This is some of the things that are going on in Denmark, in one of the new Novo Nordisk centers that has been established on quantum sensing for bio. And you can see a sensor here, which is essentially the sensors that has been already mentioned here and talked about. And it's a small glass ampoule, a small glass cell, if you want. It's about half a centimeter times half a centimeter times half a centimeter right now. And this is looking relatively innocent in the sense that how can you use that for sensing for anything? But you can actually, because if you put a little bit of atoms into that, cesium atoms into that cell, and use a laser, like the laser, almost the same sitting in this element here. If you use a laser to sort of spin polarize all the atoms, so they are already sort of pointing the same direction, all the atoms, they will be very sensitive to external magnetic fields. And that external magnetic field can actually be read out by another laser. So you have two lasers that sort of enters this glass ample. One that sort of spin polarizes this ample, and another one that actually reads out the magnetic field. And here's an example of a heart that was put close to a sensor like that, and you can see sort of the heartbeat determined by the sensor here. This is an interesting technology for this purpose here for many reasons. One of the reasons is that as opposed to EKG, this thing here, you can make a sort of a tomography now. You can put sensors now that can actually look to this specific part of the heart or to this specific part of the element that you're looking at. And this is an interesting technology because it also starts to look into what we call the conductivity around. So conductivity has something to do with how well is sort of electricity flowing there. And if you have cardiovascular problems, then suddenly the conductivity around the heart will change. And this is something that these sensors here can really measure with very, very high accuracy. The sensors here at the Niels Bohr Institute, it's your POSIX group, they're basically sensors that are a femtotesla per root hertz. So that means it's about 10 billion times less than the magnetic field of the Earth that they can detect. So you suddenly have a sensor that can sense really, really small fields. It's like having a hammer, and when you have this kind of hammer, you see nails everywhere, and you want to use it for a lot of different things. Of course, in terms of defense, there's a number of things that you can use that for. We can discuss that maybe afterwards. But in terms of, it's not only the heart, but it could also be other sort of parts of the body that you can start to image with this thing here, because electromagnetic fields happens from all parts of the body. If I stretch a muscle here, there will be electromagnetic fields happening there. You can see that. And I think actually one of the things we should think about in this regime here, since we have such good sensors right now, how about having magnetic markers attached to molecules that we put into the body? Because if you have a sensor that is that accurate here, I mean a femtotesla, 10 to minus 15 Tesla, that's a very small field. And if you have really good sensors, they can detect very minute and small things happening in your body. It could also be your brain, and I will come with a small comment on the brain as well, because I think that could also be interesting. If you administer medicine or things like that with a magnetic marker, you would be able to see which part of the body, or the brain for that matter, that this would take place. So I think there's a number of interesting things with these sensors here that really happens here, and we should think about that in the Nordic context. I think that could be very interesting. Also with the things that I saw a second ago with the fabulous talks there, I was really jumping almost out of my seat when I saw that. So this is really great to see. I think there's missing a slide, but that doesn't matter because I can remember it. So my comment here was essentially, if you look at this technology as we have seen before and put it on the head in sort of a helmet type of technology, you will have new possibilities. And I can say one of the things that has been recently demonstrated here was if you combine these sensors with sensors of AI, for example, if you combine AI with these sensors here, you can actually start to command electronics by thoughts alone. So this has been demonstrated that it shows the fast evolvement of these technologies, that you can actually now start to map out the brain and combine it with AI. The military has shown that you can actually use it to command vehicles with thoughts alone. So I think there's so many things happening in the quantum world that we should look at. That was just a small input from my side. Thanks a lot for listening.